Welcome back to session 15 of GED Science Mastery. I am glad you are here. In a chemical reaction, substances rearrange into brand new ones, but the atoms themselves are never created and never destroyed. That single rule is called the conservation of mass, and it powers a whole set of GED questions, including the classic, what total mass of product forms? Today, we make that rule completely automatic. Let's rearrange some atoms. The friendliest way to picture a reaction is a box of Lego bricks. You take apart the starting molecules, we call those the reactants, and you rebuild the same bricks into new molecules, the products. But here is the key. You always end up with the exact same bricks, the same atoms, just arranged differently. So in a sealed container, the total mass before the reaction equals the total mass after. Nothing vanishes and nothing is added. The atoms are simply rebuilt. Let's learn to read a chemical equation using the classic making of water. 2H2 plus O2 arrow 2H2O. The substances on the left of the arrow are the reactants. The substances on the right are the products. Two kinds of numbers matter. The big number in front, the coefficient, tells you how many molecules there are. The small number below, the subscript, tells you how many atoms are inside one molecule. So in 2H2, the 2 in front means 2 molecules, and the little 2 means each has 2 hydrogen atoms. Now the rule in numbers, because the GED loves this calculation. In a sealed flask, suppose 4 grams of hydrogen react completely with 32 grams of oxygen. How much water forms? Since no atoms are lost, you simply add the masses of the reactants. 4 grams plus 32 grams equals 36 grams of water. That is it. In any closed system, the total mass of the products equals the total mass of the reactants. So if the reactants weigh 50 grams, the products weigh 50 grams. Every time. A balanced equation has the same number of each atom on both sides. Let's check our water equation. On the left, 2H2 gives 4 hydrogen atoms, and O2 gives 2 oxygen atoms. On the right, 2H2O also gives 4 hydrogen atoms and 2 oxygen atoms. 4 hydrogens and 2 oxygens on each side. It is balanced. And here's a rule you must never break. To balance an equation, you change the coefficients, the big front numbers, never the subscripts. Changing a subscript would change the substance itself into something else entirely. Let's read a real GED-style experiment. A student mixed baking soda and vinegar 2 different ways. In an open cup, the mixture fizzed, and when it was weighed afterward, the total mass was less than before. But in a sealed plastic bag, the same amounts fizzed, yet the total mass stayed exactly the same. So we have a puzzle. Same reaction, but the open cup seems to lose mass while the sealed bag does not. In the next step, we will solve that puzzle with conservation of mass. Let's solve the puzzle. Why did mass appear to drop in the open cup but hold steady in the sealed bag? Read. Both setups fizzed, which means a gas, carbon dioxide, was produced. The open cup lost mass. The sealed bag did not. Choose. The fizzing makes carbon dioxide gas. In the open cup, that gas escaped into the air, so the mass left behind looked smaller. In the sealed bag, the gas was trapped inside, so all the mass stayed and the reading did not change. Mass was conserved the whole time. Check. Mass was never actually destroyed. The open cup only seemed to lose mass because gas floated away. How do you know a chemical change actually happened? Watch for the telltale signs. A new gas forming and bubbling, a color a change in temperature, getting hotter or colder, light being released, or a solid suddenly forming in a liquid. Any of these hints that new substances are appearing. But one gentle warning: bubbles do not always mean chemistry. Boiling water bubbles too, and that is only a physical change. So read the context and look for a genuinely new substance. Let's lock in the traps. 1. Thinking mass disappeared. No, in an open container, escaped gas only makes the mass look smaller. 2. Balancing by changing subscripts. Never. That changes the chemical itself. Change the coefficients. 3. Thinking bubbles always mean a chemical change. Boiling bubbles too, so read the context. 4. Thinking atoms are created in a reaction. No, atoms are only rearranged. The recap: atoms rearrange but are conserved. So in a closed system, mass before equals mass after. Fantastic work today, and that wraps up our chemistry block. You can now read a chemical equation, apply conservation of mass, and explain the open cup versus sealed bag puzzle. Your practice for this session is the 10 questions attached to this lesson. Answer them from memory, and for any mass problem, remember, a closed system means the product mass equals the reactant mass. To read the full lesson notes and practice more GED science questions, visit the course page at www.bridgetoexam.com. I am proud of your progress. I will see you in session 16, where we explore energy, its forms, transformations, and conservation. Keep going. You are doing great.